Hello and welcome to my session on sequences. Today we're going to cover recursive formulas, explicit formulas, and writing rules for sequences. First we need to get a few definitions out of the way. So what is a sequence? A sequence is an ordered set of numbers that usually follow some kind of pattern or rule. Alright, a recursive formula is a rule in which one or more previous terms are used to generate the next term. And an explicit formula defines the nth term of a sequence as a function of n. You'll see more of what these mean as we go through the lesson. But just to give you an example of what some of these things are, this is an example of a sequence. Notice it's just a list of numbers. The ... at the end indicates that it goes on forever and ever and ever. Here's an example of a recursive formula. So right now we don't worry about what these letters and what these symbols mean. We're going to go over that in subsequent slides. And then finally, here's an example of an explicit formula. This is what they look like. And again, we'll talk about what the n means. So what exactly do the letters mean? All right, so in the previous example here, we had the sequence 2, 5, 8, 11, ... forever and ever. The value of n, right, the n indicates the term number. So each of these numbers here we call a term, and the one that's listed first is referred to as the first term. The one that's listed second is referred to as the second term. This one here is the 8th term. 11 is the 4th term. The number after that would be the 5th term. A sub n, this little a sub n here, it's just the value of the term in that number. So notice that we could say the value of the number in the first term, or the first place here, is 2. So we say a sub 1 is 2. The value of the second term is 5. So we would say a sub 2 is 5. So this a sub 2, a sub 1, a sub 3, a sub n, it's basically just telling you, it's like naming, it's like a name for that number. So it's saying like the answer or the value of the first term is, and then it always equals something. All right. So let's talk about what this a sub n and a sub n minus 1 are, because they usually are the most confusing to students. All right, so we saw that we would call the value of the 8 here, the value of the third term is 8. Suppose we want to go on, because this sequence goes on, and we want to find the value of any term number. So we call that the nth term, or the 20th term, the 50th term, any term down down the road in the future. We call it the value of the nth term. So the term number would be n. So if we were looking for the 20th term, then this would be a sub 20. And notice the term right before that could be referred to as n minus 1. So for example, if this was the 20th term right here, the term right before that would be 20 minus 1, or the 19th term. It would be the 19th number in the list, and this would be the 20th number for a list, just to give an example. So if I call this the a sub n term, the term right before that, the value of the previous term, is referred to as a sub n minus 1. It'll become clearer after we do a few examples. So we already talked about that a sub 1 is the value of the first term. In this case, it's 2. A sub 2, as you can see, is 5. And so on and so on. A sub 3 is 8. A sub 4 is 11. So remember, these are just like the names for the answers for the terms in the sequence. And this is called the first term, this is the second term, the third, the fourth, and so on. So what is the recursive formula for our sequence that we define? 2, 5, 8, 11. All right, so a recursive formula, remember, it gives us a starting point. It tells us what the first term is, and then it tells us what to do to get to the next term. So it says, hey, if starting with, in this case, starting with the value of 2, this is what you do to get to the next term after that. So remember, the next term is n, and the one that came before it, that previous term, is referred to as n minus 1. So the very first thing you need to do to write a recursive formula is just to identify the first term. So in this case, we can see the value of the first term is 2. It's right there. It's staring at you. It's the very first number in the sequence. So that part is easy. Really easy to get the a sub 1. The next thing you do is you try to figure out the pattern. So you ask yourself, what do we have to do to get from one term to the next? So I'm looking at this list of numbers up here and I'm trying to decide, what do we have to do? What's the pattern? What do I have to do to get from one term to the next? And the very first thing I try to do whenever I'm looking at a sequence, the very first thing I try to do to figure out the pattern is see if there's something that I can add to get to the next term or subtract to get to the next term. I always try that first. So in this case, I'm going to look here and I notice that if I take 2 and I add 3, I get to 5. And then if I add 3 again, I get to 8. Then if I add 3 again, I get to 11. So it looks like we're just adding 3 each time to get to the next term. So remember what our recursive formula does. It gives us a starting value, where to start from, and then it tells us how to get to the next term. And we write it like this. I know this looks a little strange at first, but let's read it like a sentence. All this is saying here, remember what a sub n means? It means the next term. It's saying, hey, to get the next term, it means to get this number that's over here past this 11. To get that next number, you take the number that came before it, that's a sub n minus 1, and you just add 3. And that's pretty much exactly what you said. We said we just keep adding 3 each time. So that's all this means. So it says to get any term we want, we take the term that came before it and we add 3. And then we have to list the first term. We have to give ourselves a starting point. So whenever you write the rule for a recursive formula, you put in the recursive formula, that's this one, and then we list the starting term. So notice anytime we write a recursive formula, it depends on the previous term. So there's always this a sub n minus 1. So whenever you see that, you know that something's being written recursively. So what's the recursive formula for this sequence? Go ahead and pause the video and see if you can, 1, identify the first term, and then 2, write the rule that describes the pattern using a recursive formula. Alright, so identifying the first term again is really easy. It's already listed. It's just that first number in our list. And we can see that it's 10. So we write that a sub 1 is equal to 10. And then we need to figure out the pattern. So how do we get from one term to the next? And remember, the first thing I try is to see if there's a number I can add each time or a number that I can subtract each time. That's the first thing I look for. And in this case, we see that subtracting 2 works. I can start from 10. If I subtract 2, I get 8. If I subtract 2, I get 6. If I subtract 2 more, I get 4. And then so on and so on. So now we know that we're just subtracting 2 each time. Let's use that information to write our recursive formula. All right, so we write a sub n equals a sub n minus 1 minus 2. So how do I read that? Remember how we read that. It says to get to any term you want, you just take the term that came before it, that's the a sub n minus 1, and subtract 2. Which is exactly what we did, right? We just took the term. If I wanted the next term that came after the 4, I would just take the 4 and subtract 2. If I wanted the next term after that, I would take the 2 and subtract 2 more. And we could do that for infinity over and over, and that's what those little dots indicate. And then we go ahead and we write that our first term is 10, because we have to have a starting value, right? Because if I started at, let's say I started at 6 here, and then started subtracting 2, I would end up with a different sequence than the one given. The numbers would be different. So that's why you have to tell me where to start from, and then you tell me what to do to get to the next term. So take a look at this recursive sequence. This sequence. So remember, I can identify the first term easy enough. There it is looking at me. It's 1. But now I'm trying to figure out the pattern. So what's the pattern here? What do you think we have? When I'm looking at these numbers, I'm trying to see first, right, if I can add or subtract the same thing to get from one term to the next. So maybe it's adding. Let's see, if I take 1 and I add 1, I get 2. But then if I take 2 and add 1, I don't get 4. So it doesn't look like I'm adding or subtracting the same number. So when adding and subtracting doesn't seem to be the pattern, the next thing I look for is multiplying or dividing. So I ask myself, okay, so adding and subtracting didn't work. Is there something I can multiply by to get from one term to the next? So I start with the first term, and if I times it by 2, I get 2. Then if I take 2 and times that by 2, I get 4. 4 times 2 is 8. 8 times 2 is 16. That looks like it's working, right? That's defining our sequence here. So we thought about it, and we came up with the idea that it looks like we're just multiplying by 2 each time. So now how do we write that using a recursive formula? So we write a sub n, that means to get to any term we want. We have to take the term that came before it, that's this a sub n minus 1, and multiply it by 2. So we write 2 times a sub n minus 1. Right, and that's all that that means. So remember, when you're looking at a sub n minus 1, just think of that entire statement there as saying the previous term. And a sub n is meaning the next term. So we could even refer to this term as the next term, right? The one that we don't have here after 16, the one that's missing. If I want this term, when we really know it's the 6th term, right? Then I have to take the a sub n minus 1 or the a sub 6 minus 1 term or the 5th term, the one that came before it, the 16, and times it by 2. And we write that the first term was 1. So why don't you take a moment and pause the video and see if you can write the rule for this sequence. Alright, so we identify the first term. There it is. It's the first number in the list. So a sub 1 is 3. And now we got to figure out the pattern. So how did you do with that? What did you have to do to get from one term to the next? So first I might think, let's try adding again. So to get from 3 to 9, I could add 6. But then if I take 9 and add 6 again, I don't get 27. So it doesn't look like we're adding the same thing each time. That's not the pattern. So then I immediately go to multiply. So I ask myself, is there anything I can multiply 3 by to get to 9? And yeah, I can multiply 3 by 3 to get to 9. And then if I take 9 and multiply by that by 3, do I get 27? And yes, we do. And 27 times 3 is 81. So then it looks like we're multiplying by 3 each time. Alright, so now we can write our recursive formula. And say a sub n to get to the next term, we take the previous term, a sub n minus 1, and multiply it by 3. So remember, when I'm writing that 3, or in the last example, I'm just writing the 2 out in front, that means multiply it. And so it's saying take this previous term and multiply it by 3. You know, if I wanted the next term here, the a sub n term, I would take the one that came before it, the 81, and times it by 3 to get our 243. That would be the next term. So now you try this one. So this is more like what you see in your checkpoints. It says, which of these recursive formula results in the sequence below? So I went ahead and took the liberty of defining the first term as a sub 1 equals 40. Since that's the easy part, right? We can do that. You just can't forget to write it. Now we're going to go ahead and look at the rest of these and try to decide if A, B, C, or D here matches that sequence. Alright, so here I've listed out the terms. And the first thing I'm going to try to do is figure out the pattern again. So remember, I start with adding and subtracting. That's my go-to. So I start doing that, and you can notice here that these differences between consecutive terms is always 4. I just keep adding 4 each time to get from one term to the next. Alright, so now I know I'm just adding 4. So out of my list here, that eliminates options A and B, because you see both of these things say that I should be multiplying by 4, and this in B says you should be multiplying by negative 4 to get from one term to the next. So we know A and B are out of the picture. Now it's down to C or D. And they're very similar, except for that in option D we have this negative a sub n minus 1. All right, so what that would mean is to get to the second term, for example, if I wanted to find the second term, I should take the first term, I should take the term that came before it. So we can see the second term here is 44, correct? So as this is saying, though, to figure that out, I should take the first term. Okay, I take 40, then make it negative. Okay, so that's why we wrote negative 40 here. And then add 4 to that. And negative 40 plus 4 is negative 36. And that's not our answer for the second term here. That's not what the second term is. The second term is 44, not negative 36. So now we know that D is incorrect, and that leaves us with C as our final answer. And you can see that this recursive function simply says to get from one term to the next, you take the term that came before it and add 4. And we saw that that's exactly what we did. And then we had to define our starting spot as our first term was 40. Now we can use a recursive function to write out the first few terms, in this case 5 terms of a sequence. So again, they have to give you a starting point. They have to tell you at least what the first term is, and they do here. They tell me that the first term is 2. A sub 1 equals 2. And then they're going to tell me the function rule. They're going to tell me what I have to do to get from one term to the next. So let's see if I can just read this. Before I even start going through and plugging in numbers for n and all that, let me just see if I can read this statement and interpret what it means. To me it's saying, hey, to get to the next term, right, that's what a sub n means. To get to the a sub n term, to get to the next term, I should take whatever term I'm looking at, the term that came before it, and multiply it by 2. Alright, so it's saying we're starting with 2, we're starting with the number 2, and then we just keep multiplying by 2. That's how I read that. And then once you know that, writing that sequence would be easy. I could do that, right, once you know how to read it like that and say, starting with 2, I just keep multiplying by 2. That's what this statement says. So the next one would be 4, the next one would be 8, the next one I predict would be 16, then 32. Let's see if I'm right. Alright, so we're going to go ahead and we're going to write out the first term. There it is. It's been given to us. It has to be, right, to be able to write our sequence. And then you could plug in the next term value for the n, because remember, n does really represent the term number. So when I'm plugging in a 2 here, in this example here, we're showing you that the value of the second term is equal to 2 times a of 2 minus 1. There's your n minus 1. And then you can simplify this part. And 2 minus 1 is just 1. So now this is saying to get the value of the second term, I take the value of the first term, this a sub 1, that's the value of the first term, which we can see is 2, and I multiply it by 2. Okay, well, a sub 1 is 2, and 2 times 2 is 4. So the value of the second term is 4, and that's what we predicted here. So we could keep on doing more and more iterations like this with these numbers. Right, so to get to the third term, I'd have to take the second term and times it by 2. The second term is 4, so I replace this whole a sub 2 right here with 4, because that's what a sub 2 is. The value of the second term is 4. And then 2 times 4 is 8. And then we could so on and so on. We could do the fourth term the same way. We could do the fifth term this same way. So if you really want to examine the outputs here and what's written and how you do it step by step, go ahead and pause the video and write it down. Right? But you could also interpret it how we did in the beginning. So for example, if I want to know what the sixth term right now is, I really wouldn't bother going through all these little steps because I already know the pattern. I already know what's going to happen. I already know that all I have to do is take the previous term and multiply it by 2. So if the fifth term was 32, to get to the sixth term I should just do 32 times 2, which would be 64. So go ahead and take a moment and pause the video and see if you can write out the first 5 terms of the sequence defined by this recursive formula. Alright, so let's go ahead and let's start out with the given. It's telling us that the value of the first term is 5. and then the function rule here, the recursive formula that gives us. Let's see if I can interpret it and read it into English from the math. So a sub n, remember that's to get to the next term, equals, so I should do, take a sub n minus 1, remember this is the previous term, so I should, to get to the next term, I should take the term that came before it and add 7. Okay, so it's saying to get to a sub 2, the next term in my list here, because this is going to be the next term in my list, right? I should take the one that came before it, okay, 5, and add 7. So take a look at the steps here that's written. So we should take the one that came before it, that's the value of a sub 1, and add 7. And then 5 plus 7 is 12. Then we could continue this pattern and find the next step, the next value in our sequence. And 12 plus 7 is 19. Then I would take 19 and add 7 to that and get 26. And 26 plus 7 to get 33, and so on and so on. So when I'm plugging these 2's and 3's into the equations down here into our recursive formula here, it's just saying that I do want the value of the third term, and I'm just showing you that you can in fact work it out and simplify it and replace values with the previous one. Now the problem with the recursive formula is to get any term that you want, you have to know what the one before it was. So if I wanted to figure out what the 99th term in a sequence was, I'd have to know what the 98th term was. I'd have to know what the one right before it was. And that's kind of why we want to have another way to write it. And the other way to write it is called the explicit formula. And the explicit formula defines the nth term of a sequence as a function of n itself, as a function of the term number. So that means that if you want to know what the 20th term in a sequence is, all you have to do is plug in 20 for the n and you get your answer. Alright, now all arithmetic sequences represent linear functions. And by an arithmetic sequence, I mean like the sequences that we were just looking at where we had to add the same thing to get to the next term, or we had to subtract the same thing to get to the next term. So whenever you add or subtract the same thing to get from one term to another, we call that what you have to add or subtract the common difference. So whenever there's a common difference that is constant, meaning we're always adding the same thing each time, or we're always subtracting the same thing each time, then we call that an arithmetic sequence. All right, we talked about what the common difference was. It's the difference between two consecutive terms in the sequence. All right, in an arithmetic sequence, they all represent linear functions. In arithmetic sequences, right, they all have a domain of natural or numbers or the counting numbers, meaning the same thing. Because remember what the domain is. It's like the set of inputs. And the set of inputs we said was n. And n represents the term number. So if I'm looking at a list of numbers, the first number that I see is always referred to as the first term, or n would be 1. The second one would be 2. The next number would be 3, the third term, and the fourth. So you see that it always starts with 1 and then goes 2, 3, 4, all the way up to infinity. So the domain is just a set of natural numbers or counting numbers. So this is how we write the explicit formula for an arithmetic sequence. Write this formula down. This is the key to writing the explicit formula. You only need to know two things, as you can see. The values that I have indicated here in red. Right? So we already saw that a sub 1 means the value of the first term. And now the d, the other thing we need to know, is referred to as the common difference. Remember, it's what we add or subtract each time to get from one number in the sequence to the next. And then finally the n here is the term number. In this formula, it's the input variable. So it's always going to involve n. And then our answer out here, a sub n, is the value of the nth term. So this will make more sense when we do an example. Alright, so there's our arithmetic sequence formula. the first thing you do to solve these is find the common difference. So you're looking at a list of numbers, you find what you're adding or subtracting each time. Remember, if it's not adding or subtracting the same number each time, you can't use this formula. Then you identify what the first term of the sequence is. That usually just involves looking at the list of numbers and seeing what the first number is, right? And then figuring out what that common difference is, the D. So what you have to add or subtract each time to get from one term to the next. Then you plug a sub 1, the first term, and the common difference into the arithmetic sequence formula. And then finally you simplify the formula by distributing the D and then adding like terms. So let's take a look at this example. Let's write the explicit rule for the nth term of this sequence. So first I have to verify that I can use my formula that we just talked about, that it is an arithmetic sequence. And the way that I do that is I want to see if I can add or subtract the same thing to get from one term to the next. So here I go from 7 to 5 to 3 to 1. So I'm going down, so to get from 7 to 5 I could subtract 2. Then let's see if that pattern holds up. 7 minus 5 is 2 is 7 minus 2 is 5. 5 minus 2 is 3. 3 minus 2 is 1. 1 minus 2 is negative 1. So it looks like the pattern's holding up. And the way you can do that is just compare consecutive terms like we've done here. So notice again that we're subtracting 2 each time. Alright, so now we know it's an arithmetic sequence. So now I can write out my formula. So I copy down the formula and I start plugging in the known value. So I know that the very first term in this sequence, that's what a sub 1 means, is 7. There it is, it's the first term. And the common difference we just found out was negative 2. So I replace D with negative 2. Remember, if you're subtracting 2, you put it as a negative. So now I go ahead and simplify this expression by distributing the negative 2. So I have to do negative 2 times n, and I have to do negative 2 times negative 1. So when I do that, I get 7 plus a negative 2n plus 2. And then finally, notice I have like terms, 7 and 2. So I can just add those together. And 7 and 2 is 9. And then we bring down the negative 2n. So the explicit formula is a sub n equals negative 2n plus 9. Okay, so now we have our explicit formula. So what can we do with it? I mean, what is it good for? Alright, so there's our explicit formula from the previous slide. Well, what we can use it for is to find the value of any term we want. So suppose we want to find the 22nd term. That means the 22nd number in the list, in our list of numbers, right? That number that would be in the 22nd position. Remember, if I had a recursive function, I'd have to know what the 21st number was. But if I have the explicit formula, I don't need to know that. All we have to do then is let n be 22. Because remember, n represents the term number. So I want to find the 22nd term. I replace n with 22 in our equation. And then I simply work it out, and we get that negative 2 times 22 is negative 44, and negative 44 plus 9 is negative 35. So now I know that if I really needed to know what the 22nd number was in the list, we know it. It's negative 35. So how about we write a possible explicit formula for the nth term of this sequence? I'm going to let you pause the video and try it on your own. Remember, you need to first make sure that it's an arithmetic sequence, that we're adding or subtracting the same thing each time. And then you need to figure out what the first term is. Alright, so I go ahead and list the terms. And I'm checking to see if I got an arithmetic sequence here. So I notice that the difference between 5 and 9 is positive 4. I have to add 4 to get from 5 to 9. Let's see if that pattern holds up. Well, if I take 9 and add 4, I do get 13. 13 plus 4 is 17. 17 plus 4 is 21. So we do indeed here have an arithmetic sequence. So now that tells me I can use my formula for the explicit formula for an arithmetic sequence, where all I have to know is what the first term is and what the common difference is. Well, we see the first term in our list here. we can see that it is, in this case, there's a mistake on the slide. It should be a 5, right? We see that the first term here is 5. This should be 5. And we know that the common difference here is 4. So now that I plug those two into our formula, we can simplify that. I simplify by distributing the 4 to both the n and the negative 1. And remember, this number here should really be 5. So now finally I can simplify by combining like terms. And there are the like terms, the 5 and the minus 4. So we're going to get that a sub n is equal to, I copy down the first term, which is 4n, and then I can do 5 minus 4, which is positive 1. Just to make sure that this is really working, suppose I want to try to see if I can get this 13. Well, we can see that the 13 is the 1, 2, third number in our list. So what that means, if I plug in a 3 for the n right here, I should get 13 out. You know, if I plugged in a 5, remember this is the 5th term, this is the 3rd term here, here's the 4th term, the 2nd term, the 1st term. So if I plug in a 3, I should get out 13. Let's see, 4 times 3 is 12 plus 1 is 13. Yeah? If I plug in a 5, I should get out 21. So let's see, 4 times 5 is 20 plus 1 is 21. So it is working to generate our sequence. But we write a possible explicit rule for the nth term of this sequence. Alright, so I list out my sequences. I'm trying to see if there's something I add or subtract each time. And it looks like subtracting 3 is doing the trick. So you verify to get from 9 to 6, I subtract 3. Then we keep subtracting 3. Alright, so it's an arithmetic sequence. So I can use the arithmetic formula, right? And commit that to some paper. That should be in your notes, right? So all I need to know is the first term. Oh, I can see it. It's right there. It's 9. And the common difference, oh, we found out. We're just subtracting 3. And now you just simplify that right-hand side. So I'm going to multiply, distribute that negative 3 to both the n and the negative 1. Then I combine like terms. And finally we get that negative 3n plus 12 is the explicit formula that defines this sequence. So again, if I wanted to find out what the 22nd term was, if I wanted to find out what the 100th term was, I could just plug in 100 for the n and then go negative 3 times 100 plus 12 and get my answer. So as your exit ticket, you need to make sure to go to the asynchronous session for questions, right, which you can find in your course announcements. Click on the link and then answer the questions on the Google form and click submit when finished.